Feebly open sets in ideal topological spaces part 2. This video is a continuation of the earlier one, namely part 1, which you can find on our channel, of course. Hence, this presentation is still based on the paper by Yiezi Talkany and Suadud Ismael from 2017, and you may look at the bibliography here to check this paper and to find all these original proofs and definitions and examples, because nearly all of them are taken strictly from this article. In the preceding presentation, we have discussed the very idea of ideal topological spaces. The very idea. But now we shall introduce some special classes of open sets. First, let us recall some basic definitions. Assume that Xt is a topological space and I is an ideal on X. Let us recall the word definition of ideal. It's a family which is closed, as you can see here, under taking of subsets and under finite unions. Well, so if we have this ideal, then we may define this set here, so-called local function of A star of IT. The set of all these elements, all these x's in our universe, such that if we take any of their open neighborhoods, this is written here, then the intersection of such neighborhood with our set A does not belong to our ideal, does not belong. A is said to be I open if A is contained in interior of A star. A set F is called I closed if its complement is I open. This is the notation for the set of all I open sets. And moreover, if A is contained in A star in its local function, then we say that A is star dense in itself. And if A star is contained in A, then we say that A is called T star closed. And if the sets are equal, A is equal to A star, then we say that A is star perfect. The following theorem holds if we have an ideal topological space and there are two subsets which are contained in our universe X, and we have certain non-empty index set delta, then as we can see here, if this family is contained in the set of all I open sets, so each U alpha is I open, then their union is also I open set. Moreover, if A is I open and B belongs to our topology, so B is open, then their intersection is I open. Just as in the ordinary topological space, a subset A of an ideal topological space is semi-open if it's contained in a closure of its interior. Contained in a closure of its interior. And of course, semi-closed if complement is semi-open. For example, here we have very simple topology, finite universe ABC. This is our family of open sets, and these are families of semi-open and semi-closed sets. And of course, you should check these facts, perform all these calculations. But now we have something new, something which is connected with the variety of ideals. A subset A is semi-I open if A is contained in star closure of an ordinary interior of A. Star closure, it means that it's closure of something but in terms of I open and I closed sets. So the smallest I closed set in which A is contained, or in this case, the smallest I closed set in which interior of A is contained. On the other hand, we define A as feebly open if it's contained in semi-closure of its ordinary interior. Semi-closure of interior of A. Where semi-closure is of course closure, but in terms of semi-open and semi-closed sets. And one can prove that in any topological space, every feebly open set is semi-open. Then we have feebly I-open sets, such that A is contained in semi-closure of interior of local function of A. Semi-closure of interior of A star. For example, in this case, you may also check that these calculations are valid. We have ABCD, we have this topology, singleton of D, AC, ACD, and of course empty set and the whole universe. And then we have this ideal. Of course, it's closed under unions. And one can check that in this case, the set of all feebly I-open sets is here. You may also find, and you should find, semi-open sets of X. Well, as for the properties of feebly I-open sets, they are not very strong. For example, one can prove that the intersection of two feebly I-open sets need not to be feebly I-open, but their union is open. There are also other theorems. Every feebly I-open T star closed subset A is semi-open. Every open set is semi-I-open. Every semi-I-open set is semi-I-open. Every I-open set is feebly I-open. Every I-open T star closed set is semi-I-open. Well, quite complicated. And moreover, if A is feebly open and star dense in itself, then A is feebly I-open. If A is feebly I-open and T star closed, then it's also feebly open. As I said, these things are quite complicated, but in the original paper, it's here, you may find proofs and a kind of diagram which will allow you to see these things in a more understandable and comprehensive manner. Thank you very much for your attention.